Hey, all you Kaggle masters out there,
There.
ready to dive into some generative AI?
Always.
Today we're going to go beyond the theory and get into how to make these models work in the real world, something you don't always get to see in a Kaggle competition.
Right. Definitely not.
Our guide for this deep dive is this white paper, Operationalizing Generative AI on Vertex AI. And we're skipping the philosophical debates, okay?
Right to the good stuff.
It's going to be like a crash course in building and deploying generative AI
Mm.
apps using those MLOps principles you know and love, but fine-tuned for, well, for someone with your Kaggle expertise.
One of the most fascinating things about generative AI is that it really changes things up compared to the predictive models you're probably used to on Kaggle.
Yeah, the paper talks about this shift from single-purpose models to what they call foundation models. So instead of model that's like amazing at image classification, but only that,
Hmm.
we're talking models that can handle a bunch of different tasks. It's kind of like imagine a model that could create realistic images, write different kinds of creative stuff, and answer your questions in a way that actually makes sense,
All at the same time.
all with the same underlying architecture.
Yeah,
That's the power of these foundation models.
exactly. And these models, they have what we call emergent properties. It's like they can do things they weren't specifically trained for.
So they're kind of learning and adapting as they go.
You could say that. It's amazing, but it can make them tough to control.
Yeah. And speaking of challenges, the paper really stresses this thing called prompt engineering. It's
Yeah.
basically all about getting the input, the prompt just right to steer these foundation models to do what you want.
I like to think of it as you're giving instructions to a really talented but easily distracted apprentice. You got to be super clear or they'll go off on a tangent.
Okay, I can see that. So for Kaglers, how does this prompt engineering fit into the whole competition scene?
Well, think about it. In a competition, you often have limited data and crazy deadlines. Prompt engineering lets you tap into these huge pre-trained models without training them from scratch. You're basically fine-tuning them by giving them the right context, the right instructions.
Okay, so let's say we're in a Kaggle competition, right?
Yeah.
And the task is text summarization. We could take a pre-trained language model and instead of training it on like a massive data set,
Yeah.
we use prompt engineering to make it good at summarizing text, using just a few well-crafted examples.
Exactly. That's where all these cool prompting techniques come in. You've got zero-shot prompting, where you just describe the task, no examples, and the model tries to figure it out.
Wow.
Then there's few-shot prompting, where you give it a couple of examples to show it how it's done. And for those really complex reasoning tasks, there's chain of thought prompting.
A long chain of thought.
Yeah, you walk the model through the problem step by step, like you're teaching it to think things through logically. It's super helpful when you don't have much data.
Gotcha. So it's like breaking down a complex problem into smaller bits that the model can handle one at a time.
Perfect analogy. Like, if you ask the model to solve a word problem, you guide it through understanding the problem, finding the important info, figuring out the equations, and finally getting the answer.
That makes sense. I can see how that'd be a lifesaver in a Kaggle competition. But the paper also mentions this chaining thing, which sounds even more interesting. It's like connecting multiple prompted models together, right?
You got it. It's like creating a pipeline. Each model does a specific task and passes its output to the next one.
So you're basically building a workflow like an assembly line, but for AI models.
Precisely. You can build really powerful and complex workflows this way. Imagine combining a model that extracts information from text with one that analyzes sentiment and another one that writes creative summaries.
Whoa, okay, but that sounds like it could get really messy really fast, trying to manage all those models.
You're telling me. It's a whole new level of complexity for development and MLOps. You can't just test models individually anymore. You have to look at the whole chain, make sure everything is working together.
Like conducting an orchestra, but with AI models.
Exactly.
Okay, so we've got these awesome foundation models. We can tweak them with prompt engineering and even chain them to build these crazy workflows. But how do these things actually work? What's the difference from the predictive models we use in Kaggle?
Well, think of traditional predictive models as specialized tools. Each one is great at a specific task, like predicting if a customer will leave or classifying images, but they're not very flexible.
Like those if this, then that's decision trees.
Exactly. They're trained for one job and they stick to it.
But these foundation models, they're more like multi-purpose tools. They've been trained on tons of different types of data. It's like they've absorbed a library's worth of knowledge.
That's a good way to put it. And because of that training, they get a deeper understanding of how the data works, whether it's words, images, or even code. So they're way more adaptable. You don't need a separate model for each task. You can use the same one and tweak it for different jobs using prompt engineering.
So it's like having one super smart AI assistant that you can train to do different things instead of a team of specialized AI bots.
Exactly. But to get that assistant to do anything, you need to give it a prompt. It's basically a set of instructions and examples, plus spots for user input.
So instead of just throwing data at it and crossing our fingers, we're giving it context, instructions, almost like we're giving a recipe to a chef and expecting them to make a delicious dish.
Perfect analogy. The white paper calls this combo of model and prompt a prompted model component.
Okay.
It's the basic building block of any generative AI application. And you have to remember that combo when you're building and testing because it's not just about the model anymore, it's how you use prompts to guide it.
So for those of us who are dying to get our hands on these foundation models, do we need to start from scratch? Or are there platforms to help us out? Because building a whole AI system from the ground up is a little intimidating.
Thankfully, there are platforms that make things easier. Vertex AI, which is what this white paper is all about, has something called Vertex Model Garden. It's basically a curated collection of foundation models, some from Google, some open source. It's your one-stop shop for finding the right model for your needs.
So it's like instead of hunting down different models and trying to figure out how to make them work together, we can go to Model Garden and have a look at a bunch of pre-vetted models all ready to go in our Vertex AI project.
Exactly.
That would save a ton of time.
And to make things even easier, Model Garden gives you all the info about each model, capabilities, limitations, best use cases. It's like a product catalog for AI.
So we can compare models, see which ones are right for our task, even get an idea of how they'll perform. That's incredibly helpful.
Right. And Model Garden doesn't just help you find models, it also helps you customize and deploy them. You can fine-tune them with your own data, play around with different prompts, and even build complex chained workflows, all within Vertex AI.
Powerful stuff.
It is.
And for the more hands-on coders out there, for those of us who like to experiment, Vertex AI also has Vertex AI Studio and notebooks.
Oh, yeah, that's where you can really get creative.
Exactly. It's like a virtual playground for AI development.
You can write code, test prompts, see your results, and even work with others, all in one place.
And it's all integrated with the rest of Vertex AI, so we can smoothly go from experimenting to training, tuning, and deploying our models all on the same platform.
It's a really slick workflow,
Yeah.
built to support you through the whole development lifecycle.
This is exciting stuff. But before we get too carried away with building and deploying, let's talk about something that often gets forgotten in all the AI excitement: data.
Oh, that's a crucial point. And data plays a big role in generative AI, but it's used differently than in traditional machine learning.
Right. So in traditional ML, the model's behavior is shaped by the data it's trained on. Biased data means a biased model.
Yeah.
But with generative AI, these foundation models already come with a ton of knowledge. So the data we give them during prompting and customization plays a different role.
You're absolutely right. Think of it this way. In traditional ML, without the right data, you can't even start building the application. But with generative AI, you can prototype and launch an app with just a little bit of data because that foundation model already has a good understanding of the world.
Okay, so the foundation model is like our baseline of intelligence, and the extra data we give it helps it get better at our specific task.
Exactly. And that opens up possibilities for rapid prototyping and experimentation. You can try out different ideas and see how the model responds to different data without spending forever collecting and cleaning giant data sets.
Huge advantage for Kagglers always working against the clock.
Right. You can focus on the ideas. But it also means we need to rethink data management in generative AI.
Yeah, how so?
Well, in traditional ML, it was all about building these pipelines to extract, transform, and load data. But in generative AI, it's more about creating pipelines to manage, evolve, adapt, and integrate different types of data from all over the place.
And that's where MLOps comes in, right?
You know it. With all this different data flying around, we need to make sure it's versioned, tracked, and reproducible. That's how we build trustworthy AI.
This is getting deep. But before we get lost in the world of data management for generative AI, we need to take a quick break. We'll be back to explore this topic in more detail in part 2 of our deep dive.
See you soon.
Welcome back to our deep dive into operationalizing generative AI.
Glad to be here.
Before the break, we were talking about how data plays a unique role in generative AI, different from traditional machine learning.
Right. We were saying how with generative AI, you can start building apps with surprisingly little data because of those powerful foundation models. They come preloaded with a ton of knowledge.
Yeah, it's like they've already got a good grasp of the world. But that
Hmm.
brings up an interesting point, right?
What's that?
The different types of data we use in generative AI.
Oh, absolutely. It's not just one big data blob.
So let's break it down. What kind of data are we talking about?
Well, for starters, there are the prompts themselves. We often forget that prompts aren't just simple inputs. They're carefully crafted instructions and examples that shape how the model behaves. So they're data, too.
That makes sense. We need to keep track of them, manage versions, just like any other data.
Exactly. Then you've got few-shot examples. They're like input-output pairs that show the model what we're looking for, like mini training sets.
It's like giving the model a quick lesson on the specific task,
You
right?
got it. Then there's what we call grounding data or augmentation data. This is data that comes from outside the model, like databases, APIs, or even real-time feeds. It helps the model connect to the real world, make sure its output is accurate and relevant.
So instead of relying only on what the model thinks it knows, we can give it fresh, up-to-date info, especially important for things like question answering, where being right matters.
Exactly. For stuff like that, you need facts. And then for tasks where the model needs to interact with other systems or do things in the real world, we can use APIs to make that connection.
Wow, the possibilities are endless. It'd be amazing to see a Kaggle competition where you have to build generative AI agents that can, like, book a flight, order food, control smart home devices.
Oh, I'd love to see that. But remember, all this data, from prompts to few-shot examples to grounding data, needs careful management.
That's where those MLOps principles we were talking about really come in.
You know it.
Yeah.
We need to make sure all this data is versioned, any changes are tracked, and we can trace everything back to its source. That's how you build AI you can trust.
It sounds like data management for generative AI is a whole different game.
It is, but luckily Vertex AI has tools to help us out. They've got a range of services to help manage and govern data throughout the AI lifecycle, like Vertex AI Feature Store.
What's that?
It's like a central hub where you store and manage all your machine learning features and embeddings, including the ones you use in generative AI.
So instead of having data spread out everywhere, we can use Feature Store to keep it organized, track its history, and make sure it's good quality.
Exactly. Plus, Vertex AI integrates with other Google Cloud services like Dataplex and Data Catalog. It's a one-stop shop for data governance and lineage tracking.
Sounds comprehensive. Okay, so we've got the data side covered. Now, how about evaluation? How do we figure out how well these complex systems are performing, especially when there might not be a single right answer?
That's a tough one. Those classic metrics like accuracy or precision, they don't always work when you're dealing with creative outputs like text, images, or music.
Right, it's not just about being right or wrong. You need to look at quality, creativity, how human the output feels.
Exactly. So we need different ways to evaluate these generative AI systems. One way is to use human judgment, get people to rate the output based on specific criteria.
Makes sense. In the end, a lot of these AI apps are meant to create things that humans will find engaging and useful. But relying only on humans to do the judging can take forever and be pretty subjective.
Very true. So we need to look at automating things. One cool approach is to use another large language model as the evaluator.
Wait, AI judging AI, that's wild.
Right. It's an exciting area of research. Using an LLM as an evaluator has some advantages. It can handle tons of data fast, can be trained on specific criteria, and is way more objective and consistent than humans.
Now that would be a game changer for Kaggle competitions. Imagine an AI judge that can quickly and fairly score thousands of entries based on a set of rules. No more bias.
Exactly. And you know what? Vertex AI actually has a feature called Automatic Side-by-Side or Auto SXS that does this. It uses another LLM to judge the output of different models. Really handy for comparing different approaches and seeing which one works best.
So if I'm trying to decide between two prompting strategies or two model architectures, I can use this Auto SXS to get an unbiased opinion on which one gives better results.
You got it. On top of these automated methods, there's a ton of research happening on new evaluation metrics, specifically for generative AI. They're trying to measure things like fluency, coherence, originality, even the element of surprise in the output.
So we've got a whole toolbox for evaluating generative AI. Human judgment, AI-powered evaluation, and specialized metrics.
Yeah.
But how do we know which is the best for our needs?
It depends on what you're trying to do, who your audience is, and what resources you have. If you're building a chatbot for customer service, you'll probably focus on metrics that measure how well it understands what people are asking and how helpful its responses are.
Right, because the main thing there is good communication and solving problems. But if you're building something to generate creative content, like stories or poems, the focus shifts to originality, style, and emotional impact.
Exactly. And of course, if you're in a Kaggle competition, you got to play by their rules. Use the metrics they tell you to use. Make sure your evaluation aligns with theirs.
This is really helpful. But one last question before we move on to deployment. What about evaluating the individual parts of a chained workflow, not just the whole system?
That's a great question. When you're working with chained models, it's not enough to just look at the final output. You got to make sure each component is doing its job right. Otherwise, one weak link can mess up the whole chain.
It's like debugging a complex piece of software,
Right.
right? You need to isolate each part and make sure it's working before you can trust the whole thing.
Precisely. And that's where monitoring comes in. We need to keep an eye on our models in production to make sure they're behaving as expected.
Makes sense. But how do you effectively monitor something as complex as a generative AI system, especially when the outputs can be subjective?
That's a challenge, something we're still figuring out. But there are some things we can do. During the evaluation phase, we need to set clear performance baselines. That gives us a target to compare against once the model is live.
So we're setting the bar for how well the model should perform once it's out in the wild.
Exactly. And then we track key metrics over time, like the spread of the generated outputs, how often it makes mistakes or goes off the rails, and what users are saying about the quality and relevance of the results. Vertex AI has tools for all of this, and we can set up alerts to let us know if things start going sideways.
Sounds like a solid monitoring system.
Yeah.
But there's one more thing. We talked about how generative AI models can learn and change over time.
Yeah.
Won't that mean our evaluation and monitoring strategies need to adapt as well?
Absolutely. As the model learns and changes, its behavior might shift, and the types of errors it makes might change too. So our evaluation and monitoring need to be flexible. We might have to tweak our metrics, retrain our evaluation models, or even come up with brand new monitoring techniques to keep up with the AI's evolution.
This is eye-opening stuff. It's like operationalizing generative AI requires a whole new way of thinking about data, evaluation, and monitoring.
It does, it really does. And that brings us to deployment, where we finally get to share our creations with the world. Can't wait to dive into that.
Welcome back. It's time for the final part of our deep dive into the world of operationalizing generative AI.
We've come a long way.
We've really dug into what makes generative AI tick, from that shift from predictive AI to getting those prompts just right, to managing all that data, and of course the MLOps magic that keeps everything running smoothly.
And now we're at the good part.
Deployment time.
Exactly. Taking all that hard work and actually setting it loose in the real world.
I'm excited to see how this works. We've talked about how complicated these systems can get, especially with chained models and all that external data.
Yeah, it's not as simple as hitting a deploy button.
So how do we make sure this deployment goes off without a hitch?
Well, deployment for generative AI, it's definitely got its challenges. But Vertex AI has a whole set of tools and services that make it way easier than it used to be.
Okay, so what are some of the big things we need to think about when we're deploying one of these systems?
First off, infrastructure. These models, especially the big foundation models, they need a lot of computing power.
Makes sense.
So your deployment environment needs the right hardware, things like GPUs or TPUs. Otherwise, it'll be like trying to run a marathon with lead shoes.
Right. We don't want our system crawling when it should be sprinting.
Exactly. And it's not just about raw power. You also got to think about latency and scalability.
So how quickly the system can respond and whether it can handle a lot of requests at the same time.
You got it. Latency is key for a lot of these applications, especially if they're interactive, like chatbots or real-time content generation. If the system takes forever to respond, users will get frustrated and give up.
I know I would. And scalability, that's about being able to handle sudden spikes in traffic.
Yeah.
Like if your system suddenly goes viral.
Exactly. You need to be able to scale up the resources without everything falling apart.
Sounds like cloud computing would be perfect for this.
You know it. Platforms like Google Cloud, they're built for this. They give you that flexibility and scalability, and you only pay for what you use.
Okay, so let's say we've got our infrastructure figured out. What are the actual steps to get our system up and running in a production environment?
Vertex AI makes this easy with something called Vertex AI endpoints. They act as a gateway between your models and the outside world. You basically expose your AI capabilities as APIs that other apps or users can talk to.
So like building a web server specifically for our AI models.
That's a great way to think about it. And endpoints handle all the messy stuff like managing traffic, scaling resources, and keeping everything secure.
That sounds super helpful. Takes a lot of the pressure off us developers.
Exactly. You can focus on the AI, not the plumbing.
Plus, Vertex AI supports containerization.
Wait, that's a huge help.
It's like packing your models and everything they need into these neat little boxes that you can easily move around and deploy anywhere.
Exactly. It makes the whole process more reliable and streamlined.
I can see why that's so popular in software development.
Oh, absolutely. And Vertex AI also gives you tools to monitor those deployed models. You can track things like latency, error rates, resource usage, and make sure everything is humming along smoothly.
Monitoring is key, especially in those early days after deployment.
Definitely. You got to catch those little problems before they turn into big headaches.
Speaking of problems, we need to talk about something really important: safety.
Oh, absolutely. We touched on this during evaluation, but it becomes even more critical when you're deploying these systems in the real world.
Right, the impact is so much bigger.
Exactly. And Vertex AI has a bunch of features to help us make sure these systems are used responsibly. One of them is citation checking.
Citation checking.
Mm.
How does that work for AI?
Well, these generative models, especially language models, they're amazing at writing human-like text.
Yeah, it's kind of scary sometimes.
Right. But sometimes they can get a little too close to existing content.
Accidental plagiarism.
Exactly. So Vertex AI does these checks to catch any potential plagiarism and flags the original sources.
That's really important, especially in academic settings or anywhere where originality is key. But what about other safety issues like bias or generating harmful content?
Vertex AI has tools for those too. They have these safety scores that assess the likelihood of the output being harmful or offensive.
So it's like a built-in content moderation system.
You could say that. And for bias, there are tools to analyze and mitigate bias in both your models and your data. It helps identify potential problems and find ways to reduce their impact.
It's good to know that Vertex AI is thinking about all these angles. But even with all these safeguards, it's still on us, the developers, to use these systems ethically and responsibly.
Couldn't agree more. Responsible AI, it's an ongoing thing, not a one-time fix. We've got to keep an eye on our systems, understand their impact, and be ready to adapt as needed.
That brings us back to the core of what we've been talking about: MLOps. It's the key to building AI that we can trust, that's reliable, and that can scale.
Absolutely. As generative AI becomes more and more common, MLOps is going to be more important than ever.
Well, this has been a fascinating journey, exploring the ins and outs of operationalizing generative AI. We've seen how powerful these systems are, the unique challenges they present, and how platforms like Vertex AI make it possible to harness that power safely and effectively.
It's been a pleasure.
It's clear that generative AI has the potential to change everything. And with the right tools, the right knowledge, and a commitment to responsible AI, we can all be part of building a future where AI benefits everyone. That's it for this deep dive. Thanks for joining us, and we'll catch you next time.